Dear students, welcome back to the third episode of solving 45 expected questions daily for NEET 2025, which will also be helpful for NEET 2026 aspirants. So today we'll be discussing important questions on aldehydes, ketones, and carboxylic acids. Remember, success is the sum of small efforts repeated day in and day out. So let's stay consistent and keep learning. Now, let us look at the questions. Question number one. Let us read. Which of the following compound is most reactive towards nucleophilic nucleophilic addition reactions? So let us see. You're given ethanaldehyde, propanone, acetone, benzaldehyde. Okay, let us see some of these aldehydes and ketones, which will be most reactive towards nucleophilic addition reaction. So the most reactive one will be B first, followed by A. Let me write the ranking here. 1, 2, last you have 3. This will be the correct sequence. Question number 2. Arrange the following in order of decreasing acidity. So if you observe carefully, the most acidic. So option C contains the most reactive methylene group, followed by option A. So I'll give you the ranking here. 1, 2, then 3. So arrange the following in order of decreasing acidity. Since C contains the most reactive methylene group followed by A and B, the correct answer will be B. A and C. Option number A. Next, question number 3. A and B, let me erase this first. A and B in the following reactions are ketone reacting with hydrogen cyanide and potassium cyanide gives A. You have to find A and B. So let us write the reaction to identify A and B. So you're given a ketone R C double bond oxygen R prime. This is treated with hydrogen cyanide and potassium cyanide. So now you have cyanohydrin. So this is your product A. Now if you further react this with lithium aluminum hydride, reduction followed by addition of lithium aluminum hydride, you will now generate this product R prime CH2 NH2. So from the options available, the correct answer will be A. Question number 4. Let me erase all this again. Yes. Acetaldehyde reacts with the following, which will be the correct answer. Is it A, B, C, D? Electrophiles, nucleophiles, free radicals, for both electrophiles and nucleophiles. So how to give the reasoning for this answer question? You have to remember acetaldehyde reacts only with nucleophiles, since the mobile p electrons of carbon oxygen double bond are strongly pulled towards the oxygen atom. And carbonyl carbon is electron deficient and carbonyl oxygen is electron rich. And the electron deficient, that is acidic, carbonyl carbon is most susceptible or likely to be attacked by electron rich nucleophilic reagents, that is by a base. So hence the typical reaction of aldehydes and ketone is usually your nucleophilic addition reaction. So answer is B. Okay. Moving on to the next question. Question number 5. Clear this. Yes. In the above sequence, what is X? Question number 5. You have to answer. In the above sequence, what is X? Remember only this sodium borohydride. Sodium borohydride selectively reduces the aldehyde group to alcohol. So back in the previous episode, we have learned when alcohol is made to undergo oxidation, it changes to aldehyde if it is primary. Now we are talking about the reverse case. So selectively, sodium borohydride will reduce the aldehyde group back to alcohol without affecting the double bond in any organic compound. Okay, so the choice of the reducing agent is very important. Sodium borohydride will be the answer. Moving on to the next question. Let us see question number 6. Clear this again. Which one of the following can be oxidized to the corresponding carbonyl compound? A 2-hydroxypropane, B orthonitrophenol, C phenol, D 2-methyl 2-hydroxypropane. It's very easy to answer. The option would be B. Orthonitrophenol will be the uh, compound that can be oxidized to carbonyl compound. Question number 7. Let us see. Question number 7. In the following sequence, let me bring this up. In the following sequence, the correct structures of E, F, and G are. See, this asterisk implies it is isotopic carbon 13. So let us learn to draw the reaction, then we can derive or come to the correct answer. Now when this compound, I'm going to, since there is no space, I'll just highlight it. When this compound, carbonyl compound is heated, what happens? First step, there will be removal of carbon dioxide, leading to the formation of this product. This will become isotopic carbon. And when you further react this is already your E with iodine in sodium hydroxide. Now it will change to two products. Let me first write the product F, phenyl, carbon double bond oxygen, and this is a salt with iodoform CHI3. So the answer will be this is the given substrate or your starting material is a beta keto acid. Okay, this part is your acidic part, and this is your alpha. It contains your this alpha carbon contains isotopic carbon. So this is alpha, this is beta, and since this is a ketonic group, you call it beta keto acid. Anyway, the answer will be option number C. Question number 8. Erase all this again. Ketones can be obtained in one step by. A very easy question. can be obtained by oxidation of tertiary alcohol with strong oxidizing agents, and ketones may be formed along with carboxylic acids. See, as for example, I can give you a simple tertiary alcohol. Let me give you here. Okay, this is a tertiary carbon. OH group is attached. Now this is your tertiary alcohol. When this is oxidized, it now changes to ketone. This ketone is your acetone, water molecule, and carbon dioxide are byproduct. On strong oxidation, okay, you will get acetic acid. So let me write here strong oxidation, you are going to get acetic acid. You can balance this equation later on. How many carbon dioxide is released by balancing here, you are going to get 2. Oxygen becomes here 8 times. Count the number of carbon here. It is balanced. So oxygen is not balanced. You can write here 4. So answer is simple. Oxidation of tertiary alcohol gives ketones. Primarily product. The primary product. Next, question number 9. The compound that neither forms semicarbazone nor oxime is, it will be this amide part. Okay. D. Question number 10. What does it say? Ethyl ester on treatment with excess of Grignard reagent, methyl magnesium bromide gives P. Identify P. This is your question. Recall that esters react with excess of Grignard reagent to form tertiary alcohol having at least 2 identical alkyl groups corresponding to Grignard reagent. Okay, to have a better understanding of this question, I will give you the general reaction. What is this? Ester. Alkyl alkanoid. When this ester is made to treat with Grignard reagent, you will now obtain alcohol. So since here Grignard reagent is methyl magnesium bromide, the tertiary alcohol should have at least 2 methyl groups. Thus, the choice with at least 2 methyl groups at the carbon link with your OH group will be the correct choice. So identify the answer. It will be option A. Fine. Question number 11. Coming to question number 11. Which of the following compounds when heated with carbon monoxide at 150 degree Celsius and 500 atmospheric pressure in the presence of BF3 forms ethyl propionate? You have to remember reaction of diethyl ether with carbon monoxide produces ethyl propionate. Let us see the reaction. Diethyl ether. This is simple ether because the alkyl groups present on the ethereal oxygens are same. Now let us react this with carbon monoxide, which is quite acidic in nature, in the presence of BF3 electron deficient compound at 150 degrees centigrade and a high pressure of 500 atmosphere. You will generate ethyl propionate. This will have a very fruity smell because this is ester. The name is called ethyl propionate. So which is the answer? D, because you're asked to find the ether. Option number D. Question number 12. Let's see. Question number 12. Benzaldehyde is obtained from Rosenmann's reduction? This is concept based question, very easy. Which will be the correct answer? It will be option B. Okay. Next, question number 13. Acetone oxime is obtained by reacting acetone with which of the following reagent? It will be hydroxyl amine. Question number 14. Yes, let me erase this. Question number 14. Which of the following statements are correct regarding the above reduction of benzaldehyde to benzyl alcohol? What is this? The reverse of oxidation. When alcohols are oxidized, it changes to aldehydes. Now it is reduction process. Okay, reduction of benzaldehyde. Question is asking which is the correct answer. To answer this question, you have to know the hydrogen atom is added to carbonyl carbon of the aldehyde in the reduction process, and it is derived directly from the other aldehyde molecule as hydride ion. The second hydrogen that is added to the negatively charged oxygen is coming from the solvent. You have to remember Cannizzaro mechanism reaction. Okay, refer Cannizzaro reaction, you will understand this. And oxidation of one molecule of the compound at the expense of other molecule of the same compound is known as disproportionation. So compare and tell the answer. One will be correct. That is, one hydrogen is coming from water as hydrogen ion, another from benzaldehyde as H minus. And one hydrogen coming from, this is wrong, disproportionation reaction is correct. So since 1 and 4 is correct, the answer will be B, 1 and 4. Okay, question number 15. A carboxylic acid can be best converted into acid chloride by using which of the following reagent? You are given PCl5, thionyl chloride, HCl. Now, using of this SOCl2 in combination with this mixture forms gaseous byproduct which can be easily removed, giving better yield, okay, of your alkanoyl chloride. I will write in formula RCOCl. And further, this is called, for you to remember easily, this name is it may be new for some of you, this is called oxalyl chloride. Okay, so oxalyl chloride is particularly easy to use because any excess of it can be easily evaporated because it has a very low boiling point of 62 degree centigrade. So to answer this question, let us write the reaction. Acid plus oxalyl chloride. You are going to get acid chloride. Can be used for Rosenman reduction reaction. Anyway, HCl plus carbon monoxide and carbon dioxide gas. So the correct answer will be yes. I have told you before, use of this thionyl chloride and oxalyl chloride forms gaseous byproduct which can be easily removed due to its low boiling point, 62 degrees Celsius. This will be the correct answer, D. Let's see question number 16. Among the given compounds, the most susceptible to nucleophilic attack at the carbonyl group is. It will be, you have to check more the magnitude of positive charge on the carbonyl group or carbon, higher will be the reactivity towards nucleophilic attack. So if you would like to draw back the structure of all these given compounds, you can write here. Ethanol chloride, acetaldehyde, Propanoic acid, and beta ketoric acid. So chlorine being more electron withdrawing than oxygen develops, it will develop positive partial positive charge on this carbonyl group, carbon. So uh, this will go back since this chlorine is more electron withdrawing in nature as compared to oxygen. See, when you look at all this, there's absence of chlorine, and this is electron withdrawing group. So it is more electron withdrawing in character compared to oxygen. So oxygen will develop, sorry, this carbon will develop partial positive charge once this chlorine pulls the electron towards itself. So answer will be A. Look, okay, let's see question number 17. Let me clear all this drawings. Question number 17, read together. Find out B in the given reactions. Benzene treated with haloalkane and gives A, but you are asked to find B, right? Subsequently, you have to write all this scheme, reaction scheme. So what must be the product, the final product B? Yes, this is the preparation method of acetophenone. Or is it the preparation method of benzaldehyde? There's two. One of this will be the correct answer. Yes, you can answer this. It will be benzaldehyde. Question number 18. Pinacolone is, what is the formula of pinacolone? First, you should know how to write the formula of pinacol. It is obtained by, pinacolone is obtained by oxidation with rearrangement of pinacol, okay? Dihydric alcohol. You can give the IUPAC name of this. OH in the vicinal carbon. So when this is oxidized and made to undergo rearrangement reaction, this is rearrangement reaction. This is pinacol. After oxidation, followed by rearrangement, it will now gives pinacolone. Can you tell the IUPAC name of pinacolone? It will be 3,3-dimethyl 2-butane 1-on. Okay. Or it can butane, butanone. Answer is B. Very easy. Question number 19. Let's see. The correct sequence of reagents for the following conversion will be. You're asked to identify the correct sequence of forming the product, the reagents for forming the product. Question number 19. So what you have to do, you have to convert CHO. When you add Tollens reagent, what is Tollens reagent? Ammoniacal silver salts. It can be chloride or hydroxide. When you add Tollens reagent, what happens? This aldehydic group is going to be oxidized and forms carboxylic acid. Okay, carboxylic acid is formed. Now, esterification reaction can take place by addition of alcohol. When acid reacts with alcohol, what happens? There will be formation of ester. So alkyl alkanoid is introduced. And further, when this ester is again treated with Grignard's reagent, let me put here methyl magnesium bromide, it will now change to alcohol, which is your final product. Okay, this one. So sequence of reaction is given. You have to identify the sequence. The correct answer will be question number 19. It will be uh, Tollens reagent followed by addition of methanol for esterification, then Grignard's reagent. This is the answer. See question number 20. Benzaldehyde reacts with ethanoic acid, ethanoic potassium cyanide to give. So you need to write the reaction. Benzaldehyde. Question number 20. So when benzaldehyde is refluxed with this aqueous alcoholic potassium cyanide, two molecules of benzaldehyde will condense. Okay, condensation reaction take place here and forms benzoin. Benzoin is a condensation product formed by two molecules of benzaldehyde in alcoholic potassium cyanide. So benzaldehyde, you can write here two molecules, but still I can write here for you to understand easily. Elaborate this. These are two molecules of benzaldehyde so as to undergo condensation in the presence of potassium cyanide, which is alcoholic. Hit this and you will form benzoin. You know, in condensation reaction, there will be abstraction of small molecules like water, ammonia, nitrogen, etc. What is this? This is the formula of benzoin. So expand the formula and tell the answer. It will be B. This is the formula of benzoin. Same thing. Okay. Question number 21. Let us see. Which gives lactic acid on hydrolysis after reacting with hydrogen cyanide? So you should know that on the same carbon, that is on the geminal carbon, there will be OH group as well as carboxylic acid group. So when acetaldehyde, check whether there's alpha carbon, reacts with hydrogen cyanide, it now changes to cyanohydrin. This you have learned in the theory part. Then when you undergo hydrolysis, it now generates lactic acid. The cyanide changes to carboxylic acid. Clear? So answer will be option number B. Question number 22, let's see. Reduction of this carbonyl compound to alkane can be carried out with the help of which of the following? So carbonyl carbon is present here. This C double O group can be changed to CHOH group and not this sp3 hybridized carbon. So catalytic reduction of of this carbonyl group with sodium in alcohol and lithium aluminum hydride will reduce this carbonyl to alcoholic group and not alkane. So which is the correct answer? 22 will be. This is a typical method for preparation of alkane by Wilkesner reduction reaction. Name reaction which is there in your NCRT text. Okay, let's move on to question number 23. The end product B in the sequence of reactions, haloalkane in cyanide gives a further reaction with Alkali gives B. Question is asking B. Find B. So the conversion of alkyl halide into nitrile followed by hydrolysis either in acidic or alkaline provides a method, okay, for preparing carboxylic acid containing one carbon atoms more than the starting alkyl halide. So for you to understand clearly, let us rewrite the reaction. This is your haloalkane in the presence of cyanide. This now changes to alkyl cyanide. If you further react this with sodium hydroxide hydrolysis, it will now change to salt. Can you name this salt? Sodium salt of carboxylic acid. So 23 it will be option number C. Sodium salt of carboxylic acid. Fine. Question number 24. Let's see. Phenyl methyl ketone can be converted into ethyl benzene in one step by which of the following reagents? So in all chemistry question, you should learn how to explain by writing the reaction. So let us see the structure of phenyl methyl ketone. Substituents are present here, and since this is containing ketonic group double bond oxygen, phenyl methyl carbon. Okay. Now in the presence of zinc, amalgam, and hydrochloric acid, it is changed to ethyl benzene, CH2, CH3. So this can be converted just in one step by which of the following reagents? Zinc amalgam and HCl. You can figure out what reagent is this. In the previous class, we have explained. Okay, I hope it's clear. Lucas reagent. Question number 25. Conversion of acetaldehyde into ethyl acetate in the presence of aluminum ethoxide is called. This is also a name reaction. Have you heard about Tishenko reaction? This you will find in aldehyde ketones and carboxylic acids. So when 2 moles of acetaldehyde is treated in the presence of aluminum ethoxide. Ethoxide means C2H5O. Aluminum having trivalent, so 3. It will now change to intermediate product. There will be 2 mixture, alcohol and ester. See, these two cannot live together. Once they are in close contact with each other, they are just like magnet, okay? So the product will readily change. This is a fast reaction, change to ester. Esterification is going to happen. They are like the best friends, okay? They cannot stay together for, once they meet together, they will readily change to a very stable product, fruity smelling product called ester. Now 25 will be option number C. This is a name reaction. This reaction is called Tishenko reaction. Question number 26. This is a match the column type of question. In the first column, you have Itard reaction, hydroxylation, dehydrogenation, Friedel-Crafts reaction. In column 2, alcoholic, anhydrous aluminum chloride, chromal chloride, dilute alkaline, potassium permanganate. So match the column. Let us go step by step slowly. Question number 26. Itard reaction utilizes what reagent? Remember, it uses chromal chloride. Hydroxylation takes place in dilute alkaline KMnO4. Dehydrohalogenation takes place in alcoholic potassium hydroxide. Friedel-Crafts is and using anhydrous aluminum chloride. Option number. So find out if A is 3, B is 4, C is 1, D is 2, C will be the answer. Okay. Question number 26 is done. Now let's see question number 27. I hope you are all keeping up with me. We are about to finish. An organic compound, we'll be solving 45 questions. Okay. An organic compound A upon reacting with ammonia gives B, on heating B gives C, and in the presence of potassium hydroxide reacts with bromine to give ethanamine. See, all amines will have a fishy smell. They are not pleasing in smell. So since bromine comes up, since potassium hydroxide comes up, you should know this is a name reaction called Hoffman bromamide reaction. Now, in the formation of ethanamine, it is possible only from compounds like amide. So, figure out, this is a schematic type of question. You have to find the reaction step by step. And this C can be obtained from the compound. It will be a salt, ammonium salt of carboxylic acid. So, A must be an acid. What is the name of this acid? This is your propanoic acid. On treatment with ammonia, acid and ammonia gives rise to ammonium salt. CH3, CH2, COO, NH4 plus. You can say this is a salt. When you further treat this, it forms amide. C double bond O, NH2. And again treat this with potassium hydroxide and bromine. This will be called, this part is called Hoffman bromamide reaction. CH3, CH2, ethanamine. This is your ethanamine. So the answer for this question will be option number D. Okay, acetic acid is a starting material. Because question is asking you find A. This is your A. Okay, moving on to the next question. Question number 28. Which of the following can be oxidized to the corresponding carbonyl compound? Remember, carbonyl compounds are aldehydes and ketones containing carbon-oxygen double bond, and they are obtained by the oxidation of either primary. You please go and refer to the previous episode of alcohol, phenols, and ethers. You will find oxidation of primary alcohol gives aldehydes, secondary gives ketones, respectively. So among the options, only A, that is secondary alcohol, can be the answer. Okay, that is secondary alcohol can be oxidized to ketone. So which is the correct answer? It must be 2-hydroxypropane. Question number 29. The reagents which can be used to distinguish what are ketone. Okay, one is benzophenone, another one is acetophenone. Which one is the correct answer? It will be iodine and sodium carbonate. Because this iodine and sodium carbonate react with acetophenone. The formula of acetophenone is, you can write C6H5 C double bond O CH3 acetophenone, and benzophenone, there will be two benzene ring. Okay, this is your benzophenone. Both of these can be distinguished. Only acetophenone reacts with iodine and sodium carbonate, and it gives yellow precipitate. However, benzophenone does not react. If one reacts with with sodium carbonate and iodine, and if one does not react with that, you can easily distinguish the compound. So this must be acetophenone, which gives yellow PPT on reaction with iodine and sodium carbonate, whereas this does not give any PPT. So what is the reason to distinguish this? By iodine and sodium carbonate. Okay, moving on to the next question, number 30. Let's see and read out question number 30. What is the correct sequence of reagent that is to be used in the conversion of this alcohol to acid? How to convert alcohol to acid? You should know whether this is primary, secondary, or tertiary. And you can use many reagents. You are provided different types of reagents here. First of all, let us start from this primary alcohol. When this primary alcohol reacts with phosphorus bromide, it can be phosphorus trichloride, but here you are given phosphorus tribromide. It is going to change to alcohol can form haloalkane. Okay, it is now changed to bromoalkane. You remember those reactions which you have learned in haloalkanes, haloarenes. When this is further treated with potassium cyanide, it changes to cyanide, alkyl cyanide, and acidic hydrolysis gives carboxylic acid. So the sequence of reaction will be, mm, it will be not D, it will be A. It will be A. 1, 2, 3. Not D, A. Okay. Question number 31. Sodium salt of an organic acid X produces rapid effervescence with concentrated sulfuric acid, and X reacts with the acidified calcium chloride solution to give white precipitate which decolorizes acidic solution of potassium permanganate. Identify X. Yes. So to identify X, you need to write all the chain reaction slowly, step by step. Sodium oxalate, when treated with concentrated sulfuric acid, will produce sodium sulfate, carbon monoxide, and some carbon dioxide gas as well. Since you're heating, rapid effervescence means carbon dioxide gas will be released. And when this sodium oxalate is again treated with salt like calcium chloride, here you are given calcium chloride. So let's write the reaction when sodium oxalate, since oxalic acid has two hydrogen, it is taken by sodium. The valency of oxalate is -2. Calcium chloride, it will form calcium oxalate. Remember, this calcium oxalate is not soluble. It is white PPT, precipitate. You know the saying, if you are part of the solution, you're not part of the precipitate, and vice versa. They cannot exist together. And further, if this, let me write down here, there's no more space. When this calcium oxalate is treated with potassium permanganate, strong oxidizing agent, in the presence of the sulfuric acid, okay, potassium permanganate is purple solution, very strong oxidizing agent. Potassium sulfate, calcium sulfate, manganese sulfate, okay, like those probable product, you can mention few. And since it produces rapid effervescence, carbon dioxide gas must be also released with a water molecule. So this is a colorless solution, this manganese sulfate, right? So it decolorizes this acidic solution of KMnO4. What is X? X is your sodium oxalate. Only the sodium oxalate reaction will give all these products. Question number 32. Let us see. In the set of the given reactions, acetic acid yielded product C. PCl5 and acetic acid gives A, followed by reaction with benzene gives B, followed by anhydrous aluminum chloride in the presence of Grignard reagent in ether gives C. Question is asking find C. This is a product identification reaction. So when this acetic acid reacts with PCl5, A must be ethanol chloride. When this reacts with benzene, this must be Friedel-Crafts reaction, and it is going to give your acetophenone. From this Friedel-Crafts reaction, if you again treat with this Grignard reagent, before formation of C, there will be an intermediate. Okay, intermediate are not stable. They will readily reorganize themselves and change to the final product. So the ultimate product will be what? After reorganization and followed by ether hydrolysis, this will now change to C2H5 hydroxy CH3 and a benzene ring. So this is C. What is the formula of this C? Compare with this formula. The answer will be A. Okay, you have C2H5 here. OH group is also present here. See, it is hiding inside. Okay, OH. Okay, expand it, you will get the answer. Next, question number 33. Which of the following will most readily be dehydrated in acidic condition? Which will be dehydrated readily in acidic condition? Compound A undergoes dehydration easily as the product obtained is a conjugated and thus it is more stable. So A will be the answer. Find out whether this is alpha, beta, or gamma. Okay. Next, question number 34. Which of the following contains an aldehyde? You will find this reasoning in the front page, in the introductory part of NCRT textbook. Very basic, you know. Aldehydes are present in most of the dry fruits, like almonds. Anyway, which of the following contain an aldehyde? All of this will contain aldehyde. Vanilla beans, meadow sweet, cinnamon, almonds, all of this. Question number 35. Heating the mixture of sodium benzoate and soda lime gives. Basic question. Gives what? Benzene. Question number 36. Let us read the question. We'll move faster, okay? Easy questions. Observe the following structures and pick up the correct statement. Say in structure 2 presence this one, this structure 2, can you figure out? In structure 2, the presence of positive charge on oxygen atom causes displacement of this pi electron. Okay, this pi electron will migrate towards where? Oxygen, because negative and positive they attract, making carbon more electron deficient, will become plus. And then that compared to the unprotonated carbon as compared to this will become more polar in nature. So what is the answer for this? Carbonyl carbon of 1 is less electrophilic, which means of course after migration here it will change to delta plus and delta minus, but still this oxygen is already protonated. Okay, so this will be more electrophilic in general. So carbonyl carbon of 1 is less electrophilic as compared to that of carbonyl carbon 2. I hope this is clear. Question number 36. After 36, let's say 37. Read the question. Almost finished, right? Okay, bear with me. We are only left with 8 questions. An enantiomerically pure acid is treated with a racemic mixture of an alcohol having one chiral carbon. The ester form will be. See, the optically active acid will react with D and L isomer and it forms. Okay, the look at the question. An enantiomerically pure acid is treated with a racemic mixture of alcohol having one chiral carbon. So after this ester form will be okay. So like I have told you before, the optically active acid will react with D and L forms of alcohol present in the racemic mixture after racemization takes place at different rate of formation. And it is now again going to form from that racemic mixture to distereoisomers, okay, in unequal amounts, and it can lead to the formation of optical activity of the product. So the answer for this question will be optically active mixture, because at the end it gives diastereomers. Question number 38. Let's see. Metachlorobenzaldehyde on reaction with concentrated sulfuric acid, potassium hydroxide at 298 Kelvin gives which of the following answer? Potassium metachlorobenzoate. Answer will be D. Okay, moving on to the next question, number 39. The IUPAC name of the following, if you would like me to write the reaction for this, you can refer. Meta means carbon number 4. This is your metachlorobenzaldehyde. Okay, according to the question, you have to treat with concentrated potassium hydroxide. After treating with this, it becomes a salt, sodium benzoic acid. In the meta position, you have chlorine, and one will change to alcoholic. This is your chlorobenzyl alcohol. Okay, answer was D. Okay, meta position chlorobenzoid and metachlorobenzyl alcohol. Okay, let's see question number 29. The IUPAC name of the following will be. How to name this? Start counting. 1, 2, 3, 4. 4 hydroxy, 2 methyl. As a whole, this is benzaldehyde, so C. 4 hydroxy, 2 methyl benzaldehyde. This is the answer for question number 39. Question number 40. The correct order of increasing acid strength of the compounds. The correct order of increasing strength of acid this compound will be, so this one, it has 3 fluorine, very acidic in nature. This must be the first, then followed by this carboxylic acid containing group 2. This is also carboxylic acid, but you should know this, there are plus I effect here, less pronounced in A. This is 3. Last is D. Sequence, make it in proper arrangement. It will be D, A, B, and C. Electron withdrawing groups increases the acidic strength. That is a key point you have to remember. And electron donating group decreases the acid strength. So the sequence will be D, A, B, C. Let us see the next question again. The increasing order of the rate of hydrogen cyanide addition to compound AD. See, addition of hydrogen cyanide to carbonyl carbon is nucleophilic addition reaction. The order of reactivity of carbonyl compound is the smallest to the highest, okay, for aldehyde, and for ketone, smaller to higher. If I make the sequence in a proper way for aldehyde, then you have your ketone, then you have your acetophenone, and so on. You can also write benzophenone here. This is your benzophenone. Remember, lower reactivity of ketone is due to presence of 2 alkyl group. Okay, see you have here 2 alkyl group. Can you see? Which was plus I effect, plus I effect. And also you will also have this plus I effect, plus I effect. The reactivity of ketone decrease as the bulky size or as the size of alkyl group increases. So this is the logical reasoning why the increasing order of the rate of addition of HCN to compound A to D is decreasing. Okay. So arrange the following A to D. I have given you the sequence here. 41 will be D, the list. Okay, can you relate with this? D, list, followed by C. Make the ranking 4, 3, 4, 3, and this will be 2, 1. So if you arrange properly, it goes D, C, B, A. D, C, B, A. Final D, C, B. Yes. D, C, B. Remember the key point is the lower reactivity of ketone is due to the presence of two alkyl group which shows plus I effect. And the reactivity of ketone decrease as the size of alkyl group increases. That's the bottom line. Question number 42. The carboxyl functional group acid is present in which of the following? Question number 42. You should know the structure of picric acid. What is the formula of picric acid? It is 2,4,6 trinitrophenol. Okay, remember this is your picric acid A. And barbituric acid sounds scary, right? The name is, it is a heterocyclic ring. This is B. Ascorbic acid found in vitamin C. You need not remember all this formula, but for your reference, I'm giving you the structure of ascorbic acid. Vitamin C. This will be ascorbic acid. And aspirin. You know, you must be knowing the formula of aspirin, a derivative of carboxylic acid. And here you will have a ester part, or you can say methyl part. This is your structure D, and this is C. The carboxyl functional group is present in where? You can find out. It's present in aspirin. This one, relate, okay? Question number 43, last third question. Which alkane on ozonolysis gives propanaldehyde and propanone? Question number 43. Write down the ozonolysis reaction. You have double bond CH3. When this undergoes ozonolysis, what gives? It gives out ozonide. This will be unstable. Okay. When you add zinc or made to undergo hydrolysis, dehydrolysis by abstraction of water molecule, you will now get a carbonyl compound. Two types of carbon. One will be aldehyde and another will be ketone. These are some basic questions, easy questions. You have been learning this, I hope, from class 11 onwards. Still in your hydrocarbon part, right? So which is the answer for this question number 43? A. Because from this product you have to generate and try to uh, plan according to it. You have to visualize. Next question number 44. Which one of the following is reduced with zinc and hydrochloric acid to give the corresponding hydrocarbon? Question number 44. So whenever this zinc and HCl comes, this must be a Clemmensen reaction. And according to it, ketone, namely butanone, butane 2-on, when this is made to react with your zinc amalgam in the presence of HCl, Clemmensen reduction takes place. And according to it, you will form alkane. In bond line notation also you can write, okay, this must be the formula of butane. So for starting is butanone. This must be the answer. Last question. Last question is for you to do. You give the answer in the comment section. Acetal is produced by reacting an alcohol in the presence of dry HCl with acetaldehyde or ketone or ether or carboxylic acid. Fine, I'll give you 2 minutes. Anyway, you try to answer this question in the comment section. Yes, you can. Okay, that is for today's session. We covered important questions on aldehydes, ketones, and carboxylic acids, which are crucial for your NEET 2025 and 2026. And I'm expecting the answer for question number 45 from you all. Keep practicing daily because consistency is the key to success. And remember again, which I have explained in the earlier part of the introduction, that every small step you take brings you closer to the dream. Okay, so stay focused, stay motivated, and I'll see you in the next session. Thank you.